Again, see linear calories. C represents the number of calories and the M represents the number of minutes, correct? Number of minutes the person uses the machine, correct? So in order to verify option a person spends 22 minutes. Don't you need to simply plug it in 22, correct? And then see if the calories is similar to this. Of course, there is no calculator. You have to know how to multiply. So 13.2 times 22 plus 20.5. Now look at the calculations of how I am going to do it. Imagine that is 132. 132 times 22. Of course, I can bring back the decimal point later, right? 22 times 100. 2200. 22 times 3. What is 22 times 3? 60. So, sorry, 22 times 30, because that's 100 plus 30 plus 2, right? Okay, what is 22 times 30? 660. And 22 times 2? So what do you get? 2. What is, that's 8. Am I right? And then that's a 9, sorry, 8. And then that's a 2. And then, am I right? Did I mess it up? Is it 13.2? 22, yeah. 132 times 2, 22 times 100 is 2200. 22 times 30 is 660. 22 times, oh, there's a 44. What the heck I'm doing? Okay, 44. So that's a 4. And then what is 6 plus 6 plus 4? 10. And then that becomes 9. And then something is off. 2200, 660, 44, yeah. 4, 6 plus 4 is 10, 9290. What am I missing here? Yes. You know what? Hang on. Just my. Okay. Hey, hang on. Got. Okay. 2200 and then 660 and then 44. Okay. So that's a 4 and then that's a 10 and yeah. Yeah. So what do you get? That's 9 and then 6. There you go. So because of the decimal point, this becomes that, right? Next, there is a plus 20.5. So what would you get? 9, 0, 1. There you go. And if you round it to 311. So there you go. Right? Well, I made a mess. Okay. And then I'm sure most of you figured this part out, right? Some of you may not know what is directly inversely. Is that the gap? Some of you may have, right? Now let's close the gap. Whenever a linear equation, whenever you are dealing with a linear equation, right? It is always directly proportional without a doubt. That's one statement we can memorize, but here is the proof. Let me ask one question. If I run for more minutes, will I burn more calories or fewer calories? If I run for fewer minutes, will I run fewer calories or more calories? Fewer calories, right? That means when one increases, other one also increasing. When one decreases, other one also is decreasing. When arrows are pointing in the same direction every time, that is directly proportional. Got it? If the arrows are heading in the opposite direction, that is inversely. If they're heading in the same direction, that is directly. Is that clear, everyone? Okay. If anyone has any doubt about, okay, can you give an example for inversely? Anyone wants to know that? Huh? Inversely? Okay. Let's say you have $100 in your piggy bank. If you take 2 times 2 2 times how much you can withdraw each time. You had $100 in your piggy bank. Your parents has said, take 2 times only. And how much each time you can take? Exactly. Let's say, and then your mom said, no, 4 times how much you can take each time. How about 5 times? 20. So as you increase, or you are increasing the number of times you can take money out of it, what happened to the amount you can withdraw each time? Decrease. You see that? As you increase one quantity, other quantity is decreasing. But the product, 5 times 20, 100. 4 times 25, 100. And then 4 times 25, 100, and 2 times 50, 100. Correct? So the product is always the amount, correct? So that means in inversely proportional, the product is the constant. Product is the constant. Got it? But in directly proportional, the ratio will always be constant. Is that making sense, everyone? Right? For example, let's say t-shirt price is $5. If I buy 5 t-shirts, how much I'll pay? 25. If I buy 10 t-shirts, 50. So if you are buying more t-shirts, the amount you pay also increases, right? So that is directly. But 50 divided by 10 t-shirts, $5 per t-shirt. 25 divided by 5 t-shirts, $5 per t-shirt. That means the ratio remains the same in directly proportional. Is that making sense now? The ratio remains the same, but in inversely, the product is constant. Is that clear, Amma? Or should I put it on the board? Let me know. Should I put it on the board? Put it on the board. Okay. So let's say directly proportional and then inversely proportional. Okay. If you, let's say the t-shirt price is $5. Okay. If you buy 5 of them, how much you pay? 25. If you buy 10 of them, how much you pay? 50. So when this quantity increases, this quantity also increases. That is directly proportional. Got it? If you observe, let's say this is Y and X. Let's say this is Y and X. Isn't this one constant? The t-shirt price? Isn't that one constant? The t-shirt price. Which means Y is equals to K times X, where K is a constant. Is that clear? If you divide 25 with a 5, don't you get 5? If you divide 50 with a 10, don't you get 5? That means the ratio of the ordered pairs is the same. Do you all agree? The ratio is the same. Y1 over X1, 25 over 5, $5. If you paid 50 and if you bought 10 t-shirts, t-shirt price is still $5. So the ratio is the same in directly proportional. This is the directly proportional equation. This is the another extension you can memorize. The ratio is the same. Is that clear, all of you? Now let's talk about your inversely proportional. In the inversely proportional, let's say you have $100 in your piggy bank. If you take 2 equal amounts, how much you can take each time? 50. And if you take 4 equal amounts, how much you can take each time? 25. If you take 5 equal amounts, how much you can take each time? 20. So what is happening, Amma? What is happening? As you increase one quantity, other quantity is decreasing. That relationship between the two quantities is inversely proportional. Got it? But if you pay attention, this is the, let's say this is the Y value, these are the X values. If you understood the product Y times X is always the same $100. So constant. Is that making sense? 2 times $50, $100. 4 times $25, $100. And then 5 times $20, $100. The product is the same all the time, which is why this is your inversely proportional equation. You may have memorized this in your school. Remember that now? Right? And if you extend this further, no matter which ordered pair you take, it is product has to be same, correct? No matter which ordered pair you take. So you can say y1 x1 is equals to y2 x2. So you can memorize that one too. No matter which ordered pair you take, the product is the same all the time. Is that clear, Emma, all of you? Is that making sense now? Now do you understand why this is wrong? Because when you increase the number of minutes you work, the number of calories also increases. They are not going in opposite directions. They are going in the same direction, right? If you decrease, it decreases. If you increase, it increases.